All right, so what we're gonna do here is we're gonna look at a graphical and numerical approach to these, you guys. So for this front here, if I want the slope, what that really means is that I'm looking for the derivative, right? And we remember that the derivative was when we found the limit either as h approached 0, or if we wanted a specific one, might as well practice it. We said it was as x approached -1 of f of x minus f of -1 over x minus our x value, so minus -1. It's right up here on the wall. It's hard to see. And you can go over it. No, that's why it's on the wall for you. All right. And so then we need to start filling it out, right? So f of x is literally just x over x plus 2 minus f of -1. So this is going to be -1 over, what's -1 plus 2? Let's just simplify it right away. 1. No sense in writing all that, right? What? I just plugged it in -1, right? -1 plus 2 is just 1. I'm going to do that simplification right away. Over x plus 1, right? Still doing the limit here.
Sure.
Okay. Then from there, what do I need to do to this numerator? It's ugly.
Cancel.
I can't cancel anything yet. I need a common denominator, right? I got to put all this stuff together here. So that means that this side, I don't need to multiply by anything. This side, I need to multiply it by x plus 2 over x plus 2, right? So then I'm going to get x, and then over here, I'm multiplying in a -1 and another -1. So let's just get rid of those two negatives. Does that make sense?
Huh? No.
So if I'm subtracting -1 times everything, isn't it easier to just get rid of the double negative?
Yeah.
Right? Negative times negative is a positive. So let's do it that way. That'll be easier. So plus x plus 2 over our common denominator of x plus 2 over x plus 1. But rather than doing it that way, what's another way that I could get rid of this, like fraction of a fraction? Keep, change, flip. So rather than doing it this way, let's get rid of that and put it over here as our keep, change. It's kind of hard to read there. Let me move it up a bit. As this, right? You know what don't you get?
No.
You don't get any of it?
No.
Really?
What's the video?
Baby. All right, so now what can I do on the top here? I can simplify this. What's x plus x? 2x, yeah, right? So 2x or x2, either way, right? Doesn't matter the order we put the x and the 2 in. If I have 2x plus 2, can I pull out a common factor?
Yes.
What can I pull out?
2.
Good, so let's do that, because then it would be 2x plus 1, which is really helpful because I have that x plus 1 on the bottom, and that's the whole reason that I couldn't just originally substitute it in, right? Because remember, the first thing we do is we just plug it in, and we couldn't because we were going to get 0 on the bottom. So now we can get rid of that 0 on the bottom. And so now we've got our simplified equation. So we're going to take the limit as x approaches -1 of 2 over x plus 2.
And then -1.
And now we plug in -1. So then we're going to get 2 over -1 plus 2, or just 2 over 1, which is just 2. Amazing. Now, this is technically more efficient only because we only needed 1. If I then said, hey, find the slope at 4, what would have been the better way to do it? The h approaching 0, find the equation, plug in -1, and plug in 4, right? So the only reason that this is more efficient, I can't stress this enough, is because we're only looking for 1, and we don't know any more rules yet. Later on, this is going to be hyper less efficient. Okay, it'll be way less efficient.
That is f prime.
That is f prime at -1. So this is not f prime. This is specifically f prime of -1 is 2. Okay, that's a good point. So we can write it that way. Okay, that's the slope of the tangent line at -1. That's what that is. All right, you ready to draw some tangent lines? Got a ruler? You should try to find a straight edge if you can. It'll help you. All right, so now we're going to understand the derivative from a graphical and numerical approach. we got this fancy looking function over here. And so far our understanding is simply that of the derivative is that it is the slope of the tangent line drawn to the curve at a specific point. So we're going to complete this table by estimating f prime of x at the indicated x values. And then we're going to draw the tangent line to estimate its slope. Okay, so our first one here is at -7, which is this one here. And if I try to draw that in,
We have to draw.
that's,
I think it's because you started.
yeah, I don't know if I started it well. There we go. That seems. Oh, it was better, and then I moved it. But that's good. We'll leave it. It's close enough. So the estimation of that derivative, if I draw that tangent line, it looks like it's like +3, right? Like if I look at this thing, it's like over 1 up 3. So it looks like my estimation is 3. It doesn't have to be perfect. It's an estimation. Okay? Well, guys, if you can't find the slope of a line in calculus, you're probably not in the right class. No, but how do we find the slope of a line, guys? Rise over run. And if you have a graph, you don't even need to bother with the formula. You literally just count it. Look, over 1, up 1, 2, 3. So the slope is +3. Sorry, Pertuse. I didn't mean to be mean. I woke up and chose violence today. All right. Is the function increasing, decreasing, or at a relative max or min? So if you look at it, you can see the function. What is it doing? It's increasing, right? All right, now estimation of the tangent line, remember, we'll write out in our general here, slope point form. So y minus y1 is equal to mx minus x1, yeah? All right, so we know our point because it's right here. It's at -7 and 1 to -3. So this is just going to be y plus 3, right, minus -3 plus 3, equals, estimation of our derivative was 3 times x minus -7 or x plus 7. So that's it. Amazing, right? All right, let's try the next one, -6. Now let's try and switch up colors for you to make it a little bit easier here. So if I'm looking at this one, all right, I think, there we go. Oh, look at that. That was good. And then I moved it. It's still pretty good. So again, if we look at that one, over 1, up 2. So we can probably estimate that one as 2. And what is the function doing at 2? Is it increasing, decreasing, or max or min?
Increasing.
It's increasing still. Is it increasing more or less than it was before? Interesting.
Increasing at a decreasing.
So when we had an estimation of a slope of 2, it was increasing less than when we had an estimation of 3. Interesting. All right. That's going to come back, don't worry. And this point here, I'm not being creepy. Why is that creepy? I'm being cryptic.
That's what I said.
Oh, I thought you said creepy. Yeah.
You're only creepy sometimes.
Would you like us, like in the exam or something like that, to simplify the equation to be like
I don't care.
mx plus b?
Oh, as I've said before, I don't care. This is usually better for you because it's going to be more useful.
Okay.
So I just usually tell you guys leave it like this. So this is at the point -6 and 0. So that means that it's going to be y minus 0 equals our slope x minus -6 or x plus 6. All right, let's keep going with colors here. So at -4, let's go look. Oh, I like this one. This is a nice easy one. I can draw that one. Look at that tangent line. Bam. What's the slope of a flat line? Good, 0. And is that increasing, decreasing, or max or min? Right, so this is a relative max. Make sure you use that word relative, right? It is a max where we got to use relative or local. Okay? And it was at the point, what was it? -4 and 2. So this is going to be y minus 2 equals, does the rest of this matter? No, like none of this matters. So it's literally, exactly. Now, as per Pablo's question, this is where you should simplify it and write it that way. Don't leave it as y minus 2 equals 0. Write y equals 2. Okay? Making sense?
Yeah.
Fabulous. All right, let's try the next one here. Oops. So we're right here now at -2, That doesn't look steep enough.
And how do you know what angle you're supposed to put? Yeah.
Well, I have a secret.
Sure. Tell us.
This one's like kind of awkward, isn't it?
Like how do you know? How do you know?
Let's go that way.
You didn't get the.
So yeah, the idea is you touch it once. So with your ruler, guys, you're gonna like line it up and move it closer, closer, closer until it just touches at that point and nowhere else.
But there. But here, for example, Mr. Red. Say I have this ruler, right?
Yeah,
And I can touch it.
but without crossing the line, except anywhere at that point, only at that point.
Okay, sure, but I can do this like this, or I can do this like this, or I can do this like this.
No, you're crossing it more than once then.
Like how do you know?
There's literally only way, guys. If I have a curve like this, and I want to draw a line that only touches it once, right? I'm gonna like keep getting closer and closer until I only touch it once. So for instance, like if I'm doing this one, I can only touch there. If I go like this, I'm now touching it twice. I have to just barely touch it once. That's a tangent line, okay? So this one's at -2, -1, or -2, +1. What does that look like there? Maybe -2-ish? Yeah, I think we can go with -2, because again, it's an estimation. We don't need it to be perfect. And what is the function doing?
Mr. Again, what? It wasn't like.
Guys, literally just count it, like down 2 over 1.
Why can it not be?
Is it perfect? No, but it's an estimation. Like I'm not gonna. Guys, if we're estimating, listen please. Guys, stop talking over me. I'm not gonna make you try and be like, oh, it's like -1.8. Like that's ridiculous. It's an estimation. Use whole numbers or maybe halves at most.
Like it's closer to -2. Okay?
Definitely not.
Why?
-2 over 3 would look like this. -3 over 2 would be that.
So I say like -1.
1, 2, 3, 1, 2. Okay, we can call it -3 over 2 if you want, sure. It's definitely not -1
How do you know it's negative?
because it's going down. All right, we'll do -3 over 2. All right, is that decreasing, increasing, max or min? Decreasing. All right, and that point was at -2, 1, so this will be y minus 1 equals -3/2 x plus 2. Guys, I hate to say this, but if you don't know how to put it in this line this late in the game, you probably really are in the wrong class. I heard somebody back there say, "Gay?"
How to put what?
Guys, we're estimating the slope. I'm not going to talk about this slope for 5 minutes. Like, I'm just not, okay? It's an estimation. You want to put it as -1, -2, -3/2, it's fine. If you put it like -4, I'm going to be like, no, it's wrong, for sure. You're okay? It's just an estimation, guys. You're really spending too much time thinking about what is it close to, okay? I promise, you'll see when we like keep going, you're going to see the more important parts of this anyway. It's not about the exact value when I'm estimating. Okay, the point of an estimation is like, am I in the right ballpark?
Okay.
Right? That's kind of the point. Because if you're not, then you can kind of go, ooh, I should like change something here. All right, we look at this one. I'm right here. I'm going to go with that one. Now, I know you're going to be like, hey, it touches it more than once. When we have a curve, remember we wrote this last time, we have like, oops, because it's going to cross it more than once when you have a curve, right? We're not talking about a circle anymore. But I think this is pretty good. It's like kind of hitting right there, and then because the curve then is, later you're going to learn changing concavity, if you haven't already learned that in pre-calc. It's going through. Yes, you remember something from pre-calc, finally. All right, anyway, it's there. All right, Matthias, since you didn't get your way last time, what do you think the estimation of this green line is?
-2.
-2.
Yes.
Okay. I mean, I would definitely go more than that. Like, look, -2 is like right here, which is like definitely in the middle, right?
No, not definitely. Like 3/4.
Okay, it's 3/4. But the point is, it's still not a whole number. So if you go to like 3, what's that one look like? I'd probably go -3. Do you see why, Matthias? Like, honestly, I'm not going to mark you wrong if you put -2 because it's an estimation. But like in this case, I know. So it's closer, right, Matthias? That's what we were saying. All right, so this time we're going to say it's -3. I feel bad. I told Matthias, and then we still changed it. Matthias, you can still tell us. Is it decreasing, increasing, relative min, or relative max? Decreasing. Pablo, you had a question?
Yes.
Okay.
Because of the you just told us about the tangent touching 2 points like it's a point. What would be a secant?
Something that goes through it twice.
Yes, but
But if you looked at that tangent line, it still didn't go through it twice. It still actually only went through it once. But regardless, the point is the secant line is like, we drew them last time. It's this. Right? If it happens to go through it again over here, this is an oops, whether it's a tangent line or a secant line, because we're localized here. That's what we're caring about. And in that local area, it crosses it twice. So it's secant. All right. What was my point there? -1, -1. So this is going to be y plus 1 equals -3 x plus 1. I don't teach next block if you want to come back then. I don't teach next block because you've got someone in your room if you want to come back then. You don't have to just if you want to. Sounds good. All right. Now I'm looking at 1. That's this guy right here. What's that one? Slope is 0. And is that a relative max or min? Relative min. And if we look at it, let's just go straight to the equation this time because we know the slope's 0, the rest of it doesn't matter. What is that one? -4. So therefore y equals -4. Amazing. I know, right? Next one. All right, so for 3 here, let's see. Here's 3. I mean, that looks pretty steep. Let's try that. Oh, no.
in those like in this one particularly, how do you know how to draw the line?
There is no way, man. That's what I told you. The way is to use your ruler and get it close. If you notice, there's a couple of them I had to draw twice. Now, I do have, like, a trick, so I can do it. But you'll learn the tricks later. All right, so what does this one look like roughly? That one's real steep. What would you guys put it at? 3?
No, like 5.
Let's see. 1, 2, 3. I would say at 4, right? Here's 3. That's too early. 5 is too late. I'd go 4. Huh? No, definitely not 3/2. That would be here. Yeah, it's got to be right at that point. So I think 4 is the closest. Julieta, you're driving me crazy. Is it increasing or decreasing? Increasing. Since I'm not looking at it now, what was my pot there? It's 3 what? What's the y coordinate of that? -1, okay. It's 3 -1. My slope is 4. So my sot is 4. So it's y plus 1 equals 4x minus 3. Amazing, right? Who went? So rude. All right, let's try 5, shall we? Oh, we like 5. 5's great. It's a flat line. What does that mean? This one is actually absolute, yes, but we're still going to call it a relative just to be in the habit because we're going to talk about absolutes later. So let's call this a relative max, and it's just living at y equals 4. All right, our last one, 7. I'm going to go with like it's probably about the exact same steepness. So let's try -4 and see if that works. 1, 2, 3, 4. Yeah, that looks pretty good to me. That looks pretty good to me, right? -4, because it looks like it's like directly opposite the one that was 4. So, is it increasing, decreasing, max or min? Decreasing. And my pot for that one was it? It's directly opposite, right? It's at -1 again. Okay, so 7, -1. The SOT is -4. This is just so I don't have to look up and down, right? So that's y plus 1 equals -4, x minus 7, right? I know I didn't write pot and SOT for all of them, but we still said it, right? But I'm just writing them down so we can kind of see, all right, that's what we're doing, right? Find that point of tangency, find that slope of tangency. All right. What do you guys notice about some of these things? Oh, buddy, you just did the most useful thing we've done this year so far. Ironic that you said it was useless. Yep. Huge. Huge. And look at that. Matthias was like, oh, I don't get it. And he didn't even listen. Can you repeat that? Exactly. Matthias, you should probably listen better. For real. All right. So that's two of our things. So if we have a positive derivative, then f of x is increasing. If we have a negative derivative, let's do it. Let's write it the other way this time. F prime of x. Then f of x is decreasing. Now the last one. Take a look at the chart again. See if you can find the last thing that's interesting there about the derivative. There we go. So when f prime of x equals 0, then f of x is a critical point, which critical points we remember are relative maximums and minimums. Cool, right? Yes. I think it's great. I think a bigger question is, did Matthias get the answer? Good. But were you paying attention this time? Because last time you were like, I don't get it. And then we explained it to you and you were like, I wasn't listening. All right. We good? I'm waiting. What am I waiting for? Paulina? Okay. I think I'm literally only waiting for Paulina. There we go. All right, let's take a look at these then. Numerically, the value of the derivative at a point can be estimated by finding the slope of the secant line, passing through 2 points on the graph on either side of the point for which the derivative is being estimated. Now, does this make sense that I should pick points that are close to the derivative that I'm trying to find or far away? Close, right? If we think about this, like if I've got some graph that looks like this, and I'm like, oh, I want to find the derivative here. And so I estimate it here and here. I'm going to get that derivative is positive. But this is clearly a negative derivative, right? So I need to pick points that are very close to the point that I'm trying to estimate the derivative for. So if I want to estimate the derivative here at 0, what am I going to do? I'm going to use the 2 points that I have that are closest, okay? So I'm going to use the point at -3 and 1 just because they're the closest ones I have. Yes? Exactly. Because this time we don't have an actual, this time we don't have the graph, so this time we're going to actually use the points, and we're going to use that formula, right? So, actually, let me write it up here. So it's like y2 minus y1 over x2 minus x1. So we can go ahead and just plug that in, right? So does it matter which one is y2 and x2? No, as long as we keep it the same. So let's go with 1. So 1 minus negative, that's x. Whew. -3 minus 2 over 1 minus -3. That was a close one. So, -5 over 4. -5/4. And is the function increasing, decreasing? What? Should be decreasing. And the estimated value of the tangent line? Well, my pot is this middle one here, right? So the pot is going to be the point 0, 1. And the SOT that we just estimated, because it's actually right there. That's the point that we're estimating. So I'm going to get y minus 1 equals -5/4 x. And that's it, right? because I don't need to write like -0. That's a waste of my time. I don't want to do that. All right. Let's keep color coding because it's been fun. If I'm going to estimate the value at 1, I want the two that are closest to it on either side. So let's go with 0 minus 1 over 4 minus 0. I get -1/4. Therefore, it should be what? Decreasing. I'm not going to bother writing pot and sot this time because we can just look at them. So this one should be y plus 3 equals -1/4 x minus 1. Amazing, right? Next one I'm checking is 4. So 2 points on either side of 4. Okay. I'm going to zoom out a little bit so I can see it at the same time here. So that's going to be -7 minus 0.
I think you did the first one wrong. Because 3 minus.
-3 minus -3 - 2 is definitely -5. Oh yeah, thanks. It's all right. Matthias distracted me and I looked at the wrong one. You're right. -7 plus 3 minus -3 over 6 minus 1. Thanks, guys. Good, good. All right. That's going to be -4 over 5. What's that going to be then? Increasing, decreasing, critical point? Still decreasing. Function's decreasing a lot.
Sir, sorry, I didn't understand. Why do we choose like the near points?
Because if I don't pick points that are nearby, I'm going to get something that's like not estimated even correct.
Why would it be wrong if we choose the exact point?
Because you can't. You can't estimate with a single point. Because for a secant line, I need 2 different points.
Not with that single point, but with the point given of the value of x and 1.
Okay, let's look at this picture up here. If I'm estimating this one right here, and I choose that point and this point, I'm going to get that it's a positive one. But it's definitely not, because the tangent line is like this and it's negative. So I need to pick points that are very close to it, or else I'm going to get something that's very inaccurate usually. Okay? You bet. All right. What was my point for that one? That was 4, 0. So y minus 0 equals -4/5 x minus 4. One more. 6. So if I'm looking at 6, I want the 2 points on either side. So what is that? 2 minus 0. Man, I don't like that I can't see it. And 10 minus 4. 10 minus 4. Which is 2 over 6. Which is what? 1/3. Is that increasing, decreasing? Increasing. Finally. All right. And what was the pot on that one? 6 what? 6 -7. Okay, so y plus 7 equals my slope of 1/3 x minus 6. Fantastic, right? Ish. All right. Okay. No, it's good. It's good. It's good. Ready? Graph of the function g of x is pictured to the right. Identify the following characteristics about the graph of the derivative g prime of x. Give a reason for your answers. Guys, what do you notice about these 2 things up here that I just asked about? Exactly. So I gave you a picture of the function. I'm not going to ask you about it. Okay, so we're now at the stage in calculus where I'm almost never going to ask you about the graph that you can see. So if you ever look at the graph and you're like, oh, it's just this point. No. We are going to ask you about the other graph. If I give you the derivative, I'm going to ask you about the original. If I give you the graph, I'm going to ask you about the derivative. And then it's going to get more.
Both derivatives are 0.
These 2 points, yes. No, it's not to confuse you. It's because that's the whole point of what we're doing. It's the whole point is to be able to interpret what a graph means and what the derivative or the rate of change would be. So that's the point. All right. So I'm not actually asking you about those critical points, so let's look at what I'm asking. The intervals, you have a question?
No, I was
Okay.
an answer.
Okay, so the intervals where f or g prime of x is less than 0. So in other words, it wants to know when it's negative, which would mean what's the original function doing?
Decreasing.
Okay, so what we're going to do is we're going to start with our reasoning. Because see, it says give reasons for your answers. Remember how that's one of your standards? G of x is decreasing, which if you want to write it out, we can write it out. Right? It is decreasing. That's our reasoning. So now let's go find out where that is. Well, where is it going to happen over here?
The 2 points.
It's going to happen here. And it's going to happen here. Right? That's the only place that the... Oh, sorry.
And negative 4.
I said it wrong.
Okay.
I just did exactly what I told you not to do because I was distracted. So the function's decreasing. So it's here. I should highlight it. Let's highlight it. And there, right?
And why then?
Why here? No, because here the function's increasing. So it's from -4 to -2, and also from 1 to, what would that be if it keeps going? Infinity. There we go. Perfect. All right, let's keep going with colors. All right, so now I want to know the intervals where g prime of x is positive. So what's the original function doing?
Increasing.
Good. So let's say because g of x is increasing. Okay, and it's increasing here and here.
So from negative
Good. Negative infinity to.
Negative 4.
Good.
and
Negative 2 to 1.
Close to 1. Good. All right, our last one, we want to know where the derivative is equal to 0. And this is what you guys tried to start with. So this is going to be because g of x has relative max or mins, right? Now, where does that happen?
Negative 4, 3.
Exactly. At these 2 points, and we're going to list them, guys. If you notice, we're kind of listing all of these in terms of...
There's one missing.
Oh, yeah, I did miss one. Sorry. You're right. There we go. So we're going to list them always in terms of x. Okay, x is our map that tells us where to go. So this is going to be at x equals -4, -2, and 1. Good? Do we feel good? Bad? Happy?
This is the only.
Now the next part's easy too.
But we should have a. No, mister. No, mister, wait.
I'm waiting.
¿Cuál es el afán?
What? What is a fan?
Like brush.
Interesting. The next thing's going to be about the normal line. Who remembers what the normal line is?
The normal line.
Yeah. Boys in the back table, you're talking too much.
It's the secant line.
No, it's not a secant line. The normal line.
I wasn't sure.
You learned this for the last like 4 years.
What did you say? The normal
What
line.
is a normal line? I'll tell you something. It's related to the tangent line. Yes. Similar.
The slope of the
It's not a slope. It's not a slope. But it's related to slopes in the sense that the normal line. I'm going to draw a picture and help you out. Let's chill. So picture to the right is the graph of f of x. Draw the tangent line to the graph of f of x at x equals 1. I don't know. I'm going to go with that roughly -2 there. Then estimate the value of f prime of 1. All right, so f prime of 1. So what does that look like it is roughly? What's the slope of that?
-2
I would say it's roughly -2.
to 1.
Right. I wouldn't say it's -1. -1 would mean that it's like that. Right? I think -2 is a really good estimate here, guys. Like it's just touching right there and nowhere else. Find the equation of the tangent line to the graph at x equals 1. All right, well, my point is at 1, 2, so it's y minus 2 equals my slope, x minus the x coordinate, so x minus 1.
Perpendicular to the tangent line.
There you go. Exactly. So our normal line means that we're going to go perpendicular to it.
So it's just like make the x.
Should be like that. So this is 90 degrees. Okay, draw this line and find the equation of the normal line. So if my original slope was -2, then what is the normal line slope?
1.
No.
2.
Well, we just said that. It's the one that's perpendicular to the point of tangent. See. So what does it mean to be perpendicular? What do you do with the slopes, guys? Yeah, there you go. We negative reciprocal, so it's 1/2. Right? If it was -2, it becomes positive, and the 2 becomes 1/2.
So I drew it super fast.
Pro- Probably. All right, so then we can draw it in, or write it in. So it's going to be the same point, right? The same point. So y minus 2 equals 1/2 x minus 1. Guys, we're going to ask you about the normal line decently often. Not all the time, but like decently. So it's good to remember that, right? Normal just means that it's perpendicular to the slope of the tangent.
An estimate because you never know the actual slope of the tangent.
No, sometimes you'll know it. Most of the time you're most of the time you're going to know it. It's not very common that you're going to be estimating the tangent line. As we learn more and more about how to do the derivative, you're going to have more and more accurate answers and less estimates.
Why did you do that perpendicular line towards the left instead of towards the right?
It doesn't matter.
I just
I'm not going to draw it either way. It's not going to change the slope.
okay, but it usually goes like all around.
Yeah, like it. Technically speaking, like that normal line would keep going.
Okay.
So it should go like this. Yeah.
Okay.
All right. Let's take a look at the next one here. Graph of the derivative h prime of x of a function h of x is pictured below. Identify the following characteristics about h of x. Give a reason. We're going to start with our reasons because that's easier. Intervals while h of x is increasing. What's my reason? Yeah, so because h prime of x, now let's be efficient. If it has a positive rate of change, that means that the derivative is what? Positive. So it's increasing. Or it's not increasing, it's positive, which means the original is increasing, right? So because h prime of x is positive, huh? I can't hear you. Yeah, it's the opposite this time, yeah. Okay, so the interval where h of x is increasing, it's when the derivative is positive. So where's my derivative positive? Well, oh, let's not do it in that color. It's like here and there, right? Because this is the derivative. So when the derivative is positive, the original function is increasing. So this means it's going to be from -2 to 1 and from 3 to infinity. Does that make sense? Kind of? So, Pertuz, why don't you give me the reasoning for why h of x is decreasing?
Because h prime, you call that h prime,
Yep,
is less than 0.
perfect, right? So it's when it's negative. That's going to be here and here, the opposite sides. So that's going to be from negative infinity to -2. And it's going to be from 1 to 3. Making sense so far?
Sure.
All right. I'm happy for you. I wish you were a little more excited about it, but all right. The value of x where h of x has a relative maximum. Oh.
Equals 0.
So it's all of them?
No.
It's all 3 of them? It's just like maximum after maximum?
It's a maximum.
-2 and -1.
So let's look at the 3 options first of all, right? Let's look at our 3 options. So our option could be here, here, or here, right? How do we know which one's which, do you think? Yeah, because when the derivative is 0, the original function was a max or min. So how do I distinguish which one do you think it is?
Because the ones that are going up, like for example, -2 is a maximum because it goes up. +1 is a minimum because it goes down, and then 3.
So what you're saying is like here, this is where the function was increasing, right? That's what this meant.
Yes.
And then it's decreasing.
Yes.
So that means that
it's a minimum.
it looks like this. No, it would switch from increasing to decreasing. Here it's going to switch from decreasing to increasing. Here It starts negative, so it's going to switch from decreasing to increasing. Do you kind of see what I'm saying? Like this goes from negative to positive. This one goes from positive to negative. This goes from negative to positive. So what's our reasoning then for a maximum? What would it need to do? Does it need to switch from minimum or like decreasing to increasing, or from increasing to decreasing? Right. So our reasoning here is going to be that it's because h prime of x switches sign from positive to negative. Yeah, the sign, right? Like just positive, negative. So where's that happening? Only at one place, only at x equals 1. Does that make sense? You guys see how we're able to distinguish that, right? Because if it's increasing and then decreasing, that's going to form a relative maximum. Exactly. So the next one's the same, except that this time it's going to be because the sign is switching in the opposite direction, right? So here, h prime of x is switching sign. Exactly, from negative to positive. And where does that happen?
X equals
Negative 2. And?
3.
Perfect. See, don't we like that? That makes sense, right? So see, Matthias, see all these things we can interpret just by like understanding the relationship between the two?
Yeah.
Okay. Guys, there's a reason, like this is a giant poster over there. That blue poster is there for a reason. Okay? And like most of the students love that poster. Helps you a lot. Okay? So let's look at this next part here. If h of negative 1 is 1/2, what is the equation of the tangent line drawn to the graph of h of x at x equals negative 1? Well, let's start with what we know. We know our pot because it was literally given to us, right? The pot was literally given to us. It's negative 1 and 1/2, right? It's given to us. And then I need to find the SOT. Now, I want you to think about that for a minute. See if you can tell me what's the SOT. How do we find it? Yeah?
F of x minus f of a over x minus a.
So we could do that, but there's going to be an easier way this time. But you're right. But we don't have the equation, so we can't do that.
So the points.
Let's look up here. What graph is that?
So
Right.
we find negative 1, 1.
So can't we just literally read this graph to find it? Like if I'm looking for it at negative 1, can't I just go to negative 1 and say, oh, 5 is literally the slope? Yeah, because it's a graph of the slopes, right?
Sure.
So the slope at negative 1, because we have the graph of f prime, is literally just 5. It's a graph of all of my possible slopes.
Can you show us, like, if we didn't have the graph, how we...
There's no way to do it, because I need the equation.
Can you repeat that?
I need the equation. If I don't have the equation, I can't find it. So, in, all right, fair point, fair point, fair point. Okay, I got called out. What? Say it again. What'd you say? Yeah, what'd you say?
Because you said never look at the exact value in the graph.
Right. So Amelia's pointing out that, like I said, if I show you a graph of h prime of x, I'm not going to ask you about it. That is mostly true, but yes, this is an exception, I guess, because here I'm saying, hey, what is the slope at negative 1? And this is literally h prime of x. This is a graph of slopes for h of x. Like that's literally what this graph is. It is all of the possible slopes, right? So that means that in this case, yes, I am going to break my rule. Amelia, you're correct. And I'm going to go and say, hey, it's 5. Because at negative 1, I don't know what the graph is. I don't know what the original function is. But I do know that my slope is going to be 5. This is the reason that they had to give us the pot. Because remember, previously, the way that I would have broken that rule is I found the pot by looking at the graph, right? And then I had to, like, you know, get the slope. Or this time, I can get the slope from the graph, and I need to be given the pot. So that means that this is going to be it's the equation of tangent line. Good. Okay. So y minus a half equals 5x plus 1. Yep. And the next one now, right? The next one's actually pretty easy. If the slope was, oh no, we got to find the slope. Never mind. Okay, so I've got a pot. And my pot is 2, negative 3. And let's find the SOT. I don't need it, but I do kind of need it. So the SOT at 2, let's go look. It's negative 2. Which means that what's the sun, the slope of the normal line?
It's
All right, guys, I flipped the number. So the SOT, I read from the graph as -2. The slope of the normal then has to be the negative reciprocal, or 1/2.
It's not negative or half.
Well, it is. It's negative 1/2. Because if it was negative, I have to make it negative. And double negative cancels. So then I'm going to get y plus 3 equals 1/2 x minus 2. The truth is, you're not going to use the normal nearly as often, guys, but we will ask you about it because it's a good way for us to just see if you understand.
How do you know he was finding the sun there?